So children, continuation of gravitation lesson, universal law of gravitation. Already hope I completed universal law of gravitation in the previous video. What did I say? F is directly proportional to product of the masses, I said. And then 1 second. So children, I said F is directly proportional to product of the masses and F is inversely proportional to square of the distance between them. Okay, and combining both the equations, we'll get m1 m2 by r square. I told in the last class. That's why I'm going a little bit fast. F is equal to g m1 m2 by r square into. Now f is equal to ma, so mg is equal to g m1 m2 by r square. I told, and one m gets cancelled. G is equal to, what did I say? Gm by r square. This is the relationship between small g and big G I told in the last class. Now today I want to say, see children, G is equal to what? Gm by r square. This G is called as acceleration due to gravity. On what factors acceleration due to gravity depends? On what factors acceleration? Universal gravitational constant is constant all over the universe. On what factors acceleration due to gravity depends? Okay, on what factors? Please say. See here, children. So, children, acceleration due to gravity is inversely proportional to r square. Acceleration due to gravity is inversely proportional to r square. Try to understand. Try to understand, children. See, this is Earth. Normally we think, but really Earth is not perfect sphere, children. In fact, it is flat. Earth is little bit flat. I'm drawing more flat, but that much it is flat. Flat means children. Try to understand. Flat means equatorial radius is more. Flat means equatorial radius. Equatorial radius is more. Polar radius is less. Okay. This radius is less. This radius is more. So these are poles, and this is equator. Try to understand. So what happens at the poles? Acceleration due to gravity. First point. What happens at the poles? I am changing the I am telling today acceleration due to gravity. What happens in different places? At poles. Children, at poles, radius is less. G is inversely proportional to radius. No, children, G is inversely proportional to radius. This I am saying it is less. If this is less, this will be more. So as polar radius is less, as polar radius is less, as polar radius is less, it is inversely proportional. No? So acceleration due to gravity will be more at poles. At poles, acceleration due to gravity will be more. Okay. Now go to equator. Let's go to equator. At equator, this radius is high. The G is inversely proportional to r square. At equator, radius is high. So acceleration due to gravity will be less. At equator, radius is more. At equator, radius is more. So G is less. Radius is more. So G is less. Try to understand. At equator, radius is more, no children. Compared to poles, radius is more. So as radius is more at equator, so gravity will be less at the equator. Gravity will be less at the equator. Did you understand the difference between the poles and equator? At poles, G is high, and at equator G is less. If you stand at the poles and equator, at equator you weight less, and at the poles you weight more, because W is equal to mg. Your weight is equal to mass into acceleration due to gravity. At poles, gravity is more, so your weight will also be more. At equator, your gravity is less, so your weight also less. Less means 30 kgs won't become 20 kgs. Little less, 100 grams, 50 grams, like that, less will come, children. That's all. Don't think that I want to go to equator, so I will weight less. Not like that. Not completely. Little change will be there. So at poles and at equator, what is happening with G, you understood now. Now I want to say with height and with depth. As you go up from the earth, try to understand. As you go up from the earth, try to understand, children. As you go up from the earth, please mute your audio devices. Mute your audio devices. See, children, this is earth. As you go up, children, this is the radius r. Now you are going up, means radius is becoming more. Radius is becoming more. We know G is inversely proportional to r square. This was original radius. Now you are going up, means overall radius is still increasing. As radius is increasing, G decreases. So as you go up, acceleration due to gravity decreases. How much it decreases? It keeps on decreasing, and you all know that once you cross 60 or 70 kilometers, you'll go into the space. In the space, everything is vacuum, no air, and your G will become zero. What is happening? I told you mute your audios. So as you go up, radius is increasing. So acceleration due to gravity decreases. So as you go away from that, you all know that after going to the space, g will become zero, and you'll feel weightlessness. Why? Because there is no gravity. As you go up, there is no gravity. Decreases also. Now in the same way, So children, till now, what we studied, children, we studied poles. At poles, G is more. We studied with equator and we studied with height. Now I'm going to tell you about depth. With depth, what happens? Children, if you go into that, you dig a hole, go. You dig a hole, go inside. Dig a hole, go inside. Dig a hole, go inside. What happens as you go inside? What happens as you go inside? Children, your effective radius decreases. Your effective radius decreases. Yes or no? Your radius is decreasing means acceleration due to gravity should anyone?
Increase, sir.
Increase.
If this is decreasing, G should increase. So as you go inside, you're telling your weight should become increase. Your weight should become more. Gravity should become more. But no, children, it won't happen. As you go down, also gravity. As you go down, also inside, gravity decreases. Why it decreases? I'll say clearly. You try to understand, children. Here we don't have any relation with the earth. Here we don't have any relation. But here we are going inside the earth, children. Once you go inside the earth, the density also comes into existence. Children, try to understand density is equal to mass by volume. Mass is equal to density into volume. Try to understand, children. Okay? Try to understand. G is equal to Gm by R square. Okay, children? G is equal to G. M means what, children? What is M? Try to understand. 1 second. What is M, children? Density into volume. Density into volume, R square. Can anyone say what is the volume of sphere formula? Volume of sphere is 4 by 3 pi r cube, 4 by 3 pi r cube by r square. Okay, this r square, this cube has gone. Now finally, G is becoming directly proportional to R radius. G is becoming directly proportional to radius. As you go inside, children, density also come into consideration. In only when you go inside, G is directly proportional to R. Only when you go inside, G is directly. In all these cases, G was inversely proportional to R. G was inversely proportional to R. G was inversely proportional to R in all the cases. But as you go inside, density also comes into existence because you are going into the earth inside. You are not talking about outside. You are going into. So density you should take. Once you take density into consideration, G will become directly proportional to R. So as you go down, radius decreases. So your acceleration due to gravity also decreases. So you should understand like this, children. Okay, those who didn't understand anything. Okay, those who didn't understand anything. Once again, small summary I will tell. Please understand, children. This picture I am sending. All of you please see, children. If you didn't copy, take the picture. Still, if you didn't understand, see the video again and again. Okay, children. No, I'm going to do this. Again, I will explain same thing. Just summary wise. So, children, Earth is like this. Equatorial radius is more. Polar radius is less. Okay, so G is inversely proportional to R square. At poles, R is less. At poles, R is less. Because R is less, gravity is more. Now at equator, R is more. At equator, R is more, so G will be less. Right, children. And as you go up, overall radius increases. So G decreases. With height, G decreases. Okay. As you go inside with the depth, only in the depth case, G was inverse directly proportional to R. I said. As you go inside, radius decreases, so gravity also decreases. In all the cases, it is decreasing except the poles. At the poles, it is increasing. At the equator, it is decreasing. With the height, as you go up, also it is decreasing. As you go into depth, also it is decreasing. Like this, you should understand. Only in this case, G is directly proportional to R square. In remaining three cases, G is inversely proportional to R square. Here, G is directly proportional to R. Why it is G is directly proportional to R also? Solvation I did in the video. We should understand these factors. What are the factors on which G depends? Pole, equator, height, depth. Suppose if any mineral deposits are there inside there. Any mineral deposits are there, here also G decreases. If any minerals are there in the earth, there also your G decreases. Decreases means don't think so much it will decrease. Very less. Point 10, point 1, point 2, like 10, like that it will decrease. In decimals it will decrease. Children. Okay. So with poles it is increasing, equator it is decreasing, height it is decreasing, depth it is decreasing, with minerals it is decreasing. This much brief explanation they won't give in your textbooks, children. Only in reference books you will get this much explanation. So whatever I told till now, you should have understanding, children. If you understand only, you can do. Okay. If you didn't understand, please check the video again and again and try to understand and please follow this. What I'll be asking question in the exam. What are the factors on which G depends? You have to explain. At poles, G is inversely proportional to R square. R is less, so G is more. At equator, equatorial radius is more, so G is inversely proportional to R square, so G decreases. As you go up, radius increases, G is inversely proportional to R square, so G decreases. As you go inside, gravity is directly proportional to radius, so it decreases. With mineral deposits, G decreases. So what are the factors? Means these 5 factors you have to write in exam 5 marks question. Okay, children, I hope you understood. If you didn't understand, please check the video. Still, if you didn't understand, you please read the reference books. Thank you so much.